So this is a direct question for triple integral. So triple integral, you see you got three integral, and then you have a add in one more variable which is z. So you integrate, this is dz dy dx. To evaluate triple integral, again, so you evaluate start from the inner, the inners here. So dz dy dx, so we evaluate respect to z first. Okay, so when you integrate respect to z, x and y are constant. X and y are constant. Then you can factor out x and y. Okay, because they are in product form, x multiply y multiply z. So when you integrate respect to z, x, y are constant, you can factor out. Then you integrate respect to z only. This is z, dz, and then dy, dx. Okay, you integrate respect to z first. So integrate z dz, you have z squared divide by 2, I factor out, and then plug in 0 to the limit is from 0 to 4 minus x squared, and then you have dy dx. So you have this is xy divided by 2. So plug in the upper limit 4 minus x squared, and then you square it. Okay, you plug in lower limit, you have 0. So now become like your double integral. Okay, so I may leave it this form 4 minus x squared power 2 dy dx. So now becomes a like double integral. So integrate respect to y where x is constant. So they are in product form also. So all the x you can factor outside. So you have x over 2, then 4 minus x squared power 2. Then integrate y dy dx. Okay, so this one you have x over 2, 4 minus x squared power 2. So integrate y dy, you have y squared over 2. Okay, put out limit from 0 to x. Okay, so half 1/4. Okay, I can factor out 1/4 outside. So you got x. This is 4 minus x squared 2. So plug in upper limit, you have x squared, so minus 0. Because half 1/4. Okay, so now so total simplify, and lastly integrate respect to x. So you have 1/4. So total x, so x squared x cubed. So 4 minus x squared 2 dx. The outer integral, you can use your scientific calculator to obtain your result directly. This one. So you have 1/4 integrates x cubed, and then 4 minus okay, x squared, and then outside squared again, limit from 0 to 2. You get the answer 8/3.
Doctor,
Yes, answer 8/3.
can you show me the way to how to plot in the into the calculator again?
You find the integral button.
Okay.
You just need to find your integral button. But those who use MS, please change your calculator. Because MS, you couldn't see the integral symbol. It's like you have like you have to, I think the MS, you have to key in this thing comma and then comma 0 comma 2, something like that. You want to see the integral, okay, symbol like this. Okay, if those who own MS, please change directly to this model, except those who have the ES model. Okay, ES model should be like this. Okay, this one. Okay, so means the question just now we want to evaluate. Okay, you just put in, click that icon, triple integral, and then just change all the limit there. Just now 0 to 2, and then 0 to x, and then 0 to, this is 4 minus x, okay, power 2. Okay, the integrand here is x multiply y multiply z. So for multiplication, okay, you must press, okay, that star there. So dz dy dx. Then you just enter. Directly you can obtain the answer 8/3. Okay, and then you may ask mapper to do it step by step. Hopefully you can get it. So you see half xy, you see, you can check whether so the inner k1, after plug in the limit, your answer should be half xy 4 minus x squared power 2. No. So you get here. Okay, this is you mean compare here. So after put in limit, you get like here. The answer half xy 4 minus x squared power 2. Okay, or okay, you can also, you can have the integral without limit. But here they don't. Okay. You want without limit, you put integrate Control C. Okay. This one is okay. int is the integrate. This is using the old version. Integrate x, y, z respect to z. Okay. You should get half x, y, z squared. So you see, okay, you can actually use software to help you to do the integration. Okay. So first of all, okay, when you integrate it without putting the limit, okay, where x and y are constant, so you factor out xy, so integrate z is z squared over 2. So this is the answer without putting the limit. After putting the limit, this is the answer. So you can check with here. So first of all, okay, integrate z, so you got xy z squared over 2. So xy z squared over 2. Okay, after putting the limit, your answer is here. So okay, and then later on you can do like this. Okay. This is a trick that I show you. If you don't know how to integrate and you don't want and you still want to show step by step. First of all, your int is integrate x, y, z respect to z. This is the answer. And then you use a mapper, plug in the limit. So this is the answer. So you can double check. Later on, when we completed the inner integral, right? This one completed. The result is here. We want to integrate respect to y. So you copy this result here. Or you just put percent. Percent means the latest output. Integrate respect to y. We should get 1 over 4 xy squared z squared. Because now this one you want to integrate respect to y. Where half, half, because in here I cannot, in mapper I cannot write anything. I cannot something. So at this step, half x is constant. All this thing is constant. So you integrate respect to y is only y squared over 2. That's why I get 1/4. 1/4 xy squared z squared. So this is the mean. You see, you compare here. Here. So you get here half 1/4 x time. This one is putting limit. This one integrate y without putting limit. You have x, and then where is it? Yeah. Why I get only x? Or they simplify already. Manual we get is actually x over 4 minus x squared power 2. Maybe they simplify already. Never mind. So up to here, and then this is a integrate respect to y. Suppose it's half x minus x squared plus 4 squared. Maybe they simplify. Let me. No, maybe the result just now is here. So correct now. Here, this result integrate respect to y. So you have y squared over 2. So total is 1/4 xy squared. 4 minus x squared over 2. And then after that, you show this this step. After put in the limit, what is the result here? After plug in the limit y from 0 to x, you should get 1 over 4 x cubed 4 minus x squared over 2. After put in the limit here. So 1 over 4 x cubed. 1 over 4 x cubed 4 minus x squared over 2. And then lastly, finally, because the outer integral, you can directly using the calculator. So what I'm going to do is just integrate. Lastly, integrate the percent mean the latest output respect to x. Let's respect to x, right? Oh, this one haven't plugged in the limit. Okay, 0 to 2. Why not correct? This one respect to x, and then lastly integrate 0 to 2. Why not get 8 over 3? Okay. 0 dx. What happened? The answer 8/3. Okay, let me check why. Okay, first step, you integrate this one without putting limit. We should get half xy z squared. Put in limit. Okay, after putting the limit into the y, into the z, so you got 4 minus x squared power 2. Okay, this one correct. Okay, after that, percent mean the latest input, so I integrate this one. Okay, or you copy it, you paste it here, integrate respect to y. Why the last two answer? Wait, integrate this one respect to y. Okay, you got 1/4 x y squared 4 minus x squared. Okay, so now plug in the limit for, okay, for the x, for the y, we get this one, got y here, 0 to x, so x squared, x cubed. Okay, and then now integrate this one respect to x. This is the answer. And then integrate this one respect to x, 0 to 2. Mhm. Mm. These two I couldn't figure why they cannot get answer. Okay, so you can do, okay, this one, because integrate respect to z. Okay, this step you can copy it, and then after putting the limit, this is a result. Okay, and then integrate respect to y. Okay, this one after putting the limit is this one. Okay, and then the last one, okay, you just, okay, directly using, okay, your calculator, mean up to this step you use your calculator, integrate. eh? Oh, but you cannot do double integral, they always dx only. Okay, integrate outside, you have 1/4 1/4. Okay, and then you integrate x cubed. So x, red color, press alpha, x cube, yellow press shift, x cube, and then bracket 4 minus, so alpha x squared. Okay, outside squared again, limit 0 to 2. We should get this one, 8/3. Okay, these two, why couldn't get? I have to check later on. So question two now. Question 1b. 2 to 3, 0 to z, 0 to y, exponent x, dx, dy, dz. Okay, so this is 1c. The outer two integral you just follow. Now integrate rho squared sin theta d rho. When you integrate respect to rho, theta is constant. So you may just integrate rho squared, and they are product form. So sin theta, you can actually put out outside of the rho there. So you integrate rho squared, you have rho cube. So I can put out here 1/3 rho cube. Okay, limit for rho 0 to phi. So sin theta here. So d phi d theta. So integrate rho squared rho cube over 3. So 1/3. I factor outside the two integral here. So sin theta, cos constant, okay, factor outside of the 0. Okay, so now this step, integrate rho squared rho cube over 3. So we give, okay, this is method. So I put M1, method for integration respect to rho. So method 1, method correct, okay. Okay, and then put up limit. Okay, put up limit. Okay, simplify it correctly. The answer 1. So this 0 pi over 3, 0 to cos theta. Okay, put out limit, we have phi cube. Because put out 0, you got 0. So you got sin theta d phi d theta. So this one, the answer. Okay, successfully, okay, plug in, simplify. So you got should be phi 3 minus 0 power 3. Phi cube minus 0 cube. So you get phi power 3. This one correctly. So answer 1. Okay. Secondly, integrate respect to phi. Integrate respect to phi. Okay, integrate respect to phi power 3. So you got phi power 4 divided by 4. Okay, 0 to, put out limit 0, okay, to cos theta. This is sin theta. Still follow. Sin theta still follow the theta. Cos sin theta, you may factor outside the phi. So you integrate phi power 3, phi power 4 divide by 4. So 1 over 3 divide 4. So total is 1 over 12. Okay. And then, so you plug in cos theta into phi. So you have a cos power 4 theta. Okay, minus cos power 4, okay, 0. Sin theta d theta. Because, okay, be careful, okay, cos 0 is 1. Here I didn't, okay, 0 power 3 is 0. That's why I can straight away phi power 3. Here, when you plug in 0, sorry, not cos power 4. This one still 0. Cos theta power 4. This one plug in 0, okay, still 0 power 4. This step you can skip, okay. So lastly, integrate respect to theta. So mean you left, okay, 1 over 12, 0 to pi over 3, okay, cos power 4 theta, sin theta d theta. Okay. So the outer integral, the outers, just directly using your calculator. So of course theta you have to change to x. Okay, so you have here and make sure in radian. Check, okay, there's a R there stand for your in radian mode. So cos alpha x, okay, here I power 4. Okay, I put bracket, so because I don't know if I put like this whether they understand. So it's better I put cos, okay, x bracket and then power 4 outside. Okay, cos you got open close bracket there. Okay, and then okay, and then multiply sin. Okay, for calculator you no need to put the multiply. They should be able to, okay, understand this multiply. But mapper you have to press that star there to stand for multiplication. Alpha x. Okay, x from 0 to pi divide 3. Okay, and then outside I want to divide by 12. Oh yeah, wrong. Never mind. Okay, put out. Okay, against, okay, 1 over 12 integrate. So bracket cos and then power 4 sin alpha x. Okay, from 0 to pi over 3. Shift pi divide 3. Okay, the answer 31 over 1920. Oh, this one get nice like the fraction form. 1920. 31 over 1920. Okay.
So untuk masuk dalam calculator tu tukar yang theta kepada x
Yeah, because the calculator is only integrate respect to x only.
Okay.
Unless you use mapper. Mapper, you can change any variable. Okay, calculator only integrate respect to x only. You cannot integrate respect to other variable. So so the outers theta you have to change to x. So if you use calculator, you can see mapper 0 to phi. Okay, phi. You find the symbol here. Where's the phi? Here. Yeah. Okay, make sure it's highlight the upper 0 to phi. 0 to phi, and then 0 to cos theta. Cos bracket theta. Okay, here. And then 0 to pi over 3. Okay, pi. Where's the pi? Pi divide 3. Okay, integrate rho squared. Rho, where's the rho? Squared is actually press power shift 6. So you go up rho squared sin theta. Theta. So you see mapper multiplication. Okay, the dot here is you press that star in your keyboard. So d rho z you change to d rho d phi. Where's the phi? D phi d theta. So in software you can change any variable, but in calculator is all this integral button is always dx. So you cannot do double or triple integral. You can only do the single integral. So that's why it's only the outer here, the last one. This one you can use a calculator, because if you do manual, it is quite still long, because cos power 4 theta sin theta you have to change in using some trigonometric formula. So you make the outer integral you are allowed to use calculator, so don't worry, because up to this step, so mark method you integrate respect to rho, put it limit. Later on put out limit phi 3, and then integrate phi 3 respect to phi power 4 over 4. This one method 1. Plug in limit, this one answer 1. The last answer 1. For 5 marks here. So this is the direct question for question 1, the easiest. So the second question is application. Find the volume of the solid G bounded by the plane x, y, z. X plus y plus z equal to 1. X plus y plus z equal to 1 in the first octant. In double integral, you can find the volume of a solid. But that solid is always mean the lower mean the solid is always mean the lower bound is on the xy plane. But in triple integral it is more flexible. First of all, to find the volume, this is if double integral also you can find the volume. You can find v stand for volume using this integral fxy dA, where this is actually volume below okay, surface Z equal fxy, okay, and its projection is region R. Okay, you know, in let's say xy here, let's say this is a region R here. This is x and y. Okay, or we put, let's say your region R is a circle. Okay, let's say your region R is a circle. Okay, unit circle with radius R unit. And then the volume you're using, double integral, is actually below the surface Z equal to fxy, and its projection is on region R. Okay, for example, you use the simple one. Let's say you have cylinder. You have the cylinder. Okay, cylinder. Let's say this one bounded by Z equal to 2. Okay, and the projections is on region R, which is on xy plane. So your region R is here. So A is actually double integral dA over region R. So if we use double integral dA over region R, dA you can be dy dx or dx dy, or use polar coordinate is r dr d theta. Okay, and then so you have double integral this is 1, double integral 1 dA over region R. This is area. So the area now, now this is your height is actually the Z, right? So you have the area multiply the height, that's why you get the volume. So this is a double integral. Double integral, the limitation is actually the projection R is on your xy plane. Okay, and then if we use triple integral, it's like this, dv over the solid G. Okay, so the solid is here. Let's say this case cylinder. Okay, the solid G. So for the triple integral, volume is triple integral 1 dv. Okay, 1 dv here. Okay, and let's say we put out the limit for you to see the double integral. Let's say I would like to find the volume of this cylinder. Okay, put up here lah. Find the volume of cylinder, okay, x squared plus y squared equal to 1, okay, bounded by z equal to 0 to z equal to 1, z equal to 2. Okay, so if we use double integral, if you use double integral, then your volume is actually z is 2, right? So this is 2, and then this is a dA over region R. Okay, the region R is actually polar coordinate, circular, then you can use polar coordinate. Okay, so you got 2 dA, you change to r dr d theta. X squared plus y squared equal to 1, so r from 0 to 1. Okay, you have the full circle, so theta 0 to 2 pi. Okay, so you integrate 2r respect to r, you will have, so you got r squared divided by 2, 0 to 1 d theta. Okay, so you have, plug in r is 1, so you have actually become d theta. Integrate 1 d theta, you have theta. Put out limit 0 to 2 pi, you get the answer is 2 pi. Okay, you can check volume of a cylinder V is actually pi r squared h. Okay, r in this case is 1, so you have pi 1 squared h is 2. So the answer is 2 pi. So this one we use double integral to find the cylinder. Find the cylinder bounded by z equal to 0 to z equal to 2. Okay, if the same equation, okay, I can also use triple integral. Okay, if I use triple integral, the volume of the cylinder, you have triple integral. Okay, and then, okay, you have like here, this is region R, this is 1. Okay, so okay, dv here, if Cartesian coordinate, you can have dz, dy, dx, or you have actually 6 orientation, or dz, dx, dy. Okay, or you want to integrate respect to y first and then dz, dx. Okay, or if and then dx, dz. Okay, or you dx first and then dz, dy, or dx first and then dy, dz. So for Cartesian coordinate, we got 6 orientation. So if the solid is parallel respect to z axis, we use you integrate respect to z first. You integrate respect to z first, and then you still got 2 orientation. Either you want dy dx or dx dy. So if dy dx, so mean you integrate mean your region R, from the region R that you have, okay, your region R. So if you use vertical bar, then you use dy dx. If you use horizontal bar, then this is dx dy. So if dy, okay, if you integrate respect to y first, mean the solid is parallel respect to y axis. Okay, and then whether you want dz dx or dx dz. Okay, this is x, this is y for these two. Okay, and then for these two, okay, so z is always vertical axis. So if you integrate respect to y first, mean the solid is parallel with y axis. Okay, later on you want dz dx or dx dz is up to, okay, if you sum the region R using vertical bar, then dz dx. Horizontal bar, then you use dx dz. So similar with the last two. The last two is if the solid is parallel with respect to x-axis, then you integrate respect to x first, and then later on dz dy or dy dz. Z always vertical. So if you use vertical bar, then dz dy. Okay, horizontal bar, then dy dz. Okay, but if you want to find the cylinder, because the region R is circular, so we have to use is so far from these three, we'll use a cylindrical coordinate, where since the solid is parallel respect to z, I cannot parallel with respect to z, so either I use the first two, but the projection region R is circular, so mean this one I will change, okay, like dA, this one, and then dA you change it to polar coordinate, which is r dr d theta. Okay, so this is triple integral. And then the cylinder is bound, okay, dz, integrate respect to z. So z is bounded from z0 until z equal to 2. Okay, so dz. Then r dr d theta. R bounded from 0 to 1, theta 0 to 2 pi. Okay, so we integrate respect to z first. So you have integrate 1 respect to z, you have z. Okay, this is 2. Z 0 to 2. Okay, r dr d theta. Okay, put out the limit for z. You have 2 r dr d theta. Okay, so this step actually similar back. Yeah, 2 r dr d theta. Similar back to double integral. So the only thing, triple integral is more flexible because the upper limit not necessary on xy plane, which is z equal to 0. So this one is more flexible. Not necessary on z equal to 0. But if you use double integral is always, okay, the volume upper limit is bounded by z equal fxy. Lower limit is on region R, which is, okay, on the z equal to 0. So this is a two different, okay, between the one difference between double integral and triple integral. Okay, any questions, okay, that you want to ask before we solve these questions? Find the volume of the solid G bounded by the plane x plus y plus z equal to 1. Okay. So that question 2a, you have the plane x plus y plus z equal to 1. Okay, you can sketch the plane. This is tetrahedron. This is tetrahedron. In the first octant, first octant is where x positive, y positive, z positive. So the intercept, okay, to get x-intercept, let y 0, z 0, you get x is 1. To get y-intercept, x 0, z 0, y is 1. To get z-intercept, let x and y 0, then you get z is 1. So this is a tetrahedron, x plus y plus z equal to 1. Okay, and then you want to find the volume. Volume is given by triple integral, okay, dv, your solid G. Okay, your solid G is actually, okay, this triangle is a surface x plus y plus z equal to 1, and then bounded by, okay, zx plane, zy plane, xy plane. So mean you want to find the volume between here by this triangle, okay, and your left wall, front wall, and the wall on the floor. Okay, so can you imagine where is the volume that you want to find? Bounded by your left wall, front wall, and the floor, and this triangle plane. Okay, so if you view it parallel respect to z, then you integrate respect to z first. Okay, you put dz. Okay, let's say you use the first orientation, dz, dy, dx. The rest you can practice. Okay, integrate respect to z, so you make z as a title. Okay, integrate respect to z, you make z as a title, so z equal to 1 minus x minus y. Okay, in the first octant, okay, mean first octant, okay, x greater than equal to 0, y greater than equal to 0, z greater than equal to 0. So lower limit of z is 0 until, okay, this tetrahedron surface, which is z equal to 1 minus x minus y. Okay, so limit of z 0 to 1 minus x minus y. Okay, so this is dz. Okay, then to put up limit for dy dx, okay, you have to sketch, okay, that 2D. So 2D, so this is y, this is x. Okay, also x-intercept is 1, y-intercept is 1. Okay, on the 2D, okay, or region R, z is 0, z 0. So you have x plus y equal to 1. Okay, to integrate respect to y, y minimum is 0, z minimum also 0. So make y as a title, so y is equal 1 minus x. Okay, so 1 minus x. Okay, lastly, limit for x must be constant. Okay, 0 to 1. So this is what we so-called application question. You got to set up your own limit. If you set up the wrong limit, then you can get at most 2 marks only for integrate dz correctly, dy correctly. Okay, any question or not here? Okay, on how to set up the limit we fix using the first one. You can try another 5 orientation using the same technique. I said you got yeah. Because this tetrahedron, I can view it parallel aspect to Z, also parallel aspect to Y or axis, or parallel respect to x-axis. So you can using all these 6 orientation should give you the same answer. So I just show you the first one. So any questions here? If no, then later on you just integrate. Just a problem of integrate. Integrate 1 respect to Z, you have Z. So limit 1 minus x minus y. Then dy dx. Okay, put up the limit. So okay, I have 1 minus x minus y. Okay, plug in 0 is 0, so I can skip that step. So dy dx. Okay, so now this is in the linear form, not product. 1 minus x minus y integrate respect to y. When you integrate respect to y, 1 minus x is constant. But they are not in the product form, mean multiplication form. So you cannot factor out 1 minus x outside like that. You can factor out provided this is 1 minus x multiply y, but this is minus y. Okay, so look like you have a constant. Let's say this is 2 minus y, something like that. Okay. So now integrate respect to y. So 1 minus x as a group, this is constant. So you have a constant multiply with y. So integrate y, you have y squared over 2. Here I cannot factor out over 2 because this one got not 2. So I didn't factor out. Okay, just carry it like this. Limit 0 to 1 minus x. So dx. Okay, so when you integrate respect to y, make sure you plug in into y. Because here also x, plug in into y. Because you integrate respect to y. So this one you plug into y. Plug in 0, okay? 0, 0, everything 0. So you can skip the 0 substitution there. So you have 1 minus x, okay, and then 1 minus x again. So minus, okay, plug in y, so you got 1 minus x squared divided by 2 dx. Okay, simplify first before you plug in into your calculator. So 1 minus x times 1 minus x, 1 minus x squared. So minus 1 minus x power 2 divided by 2. Okay, so dx. Okay, simplify. Here. So if you want same thing, you multiply by divide by 2, then you times 2. Okay, or actually 1 minus half. So that's why you get 0 to 1 half of 1 minus x power 2 dx. 2 minus 1 over 2. Okay, now use your calculator. Okay, you can put inside the integral or outside the integral, doesn't matter. Okay, 1 minus alpha x squared. 0 to 1. Okay, the answer is 1 over 6. Volume. Okay, any questions here? Okay, find the volume. Okay, find the volume of the solid G bounded by planes y plus z equal to 1, y equal to x squared, xy plane and yz plane. Okay. Okay, sometimes we cannot imagine the plane. We have what? Question 2b. We want the volume bounded by the plane y plus z equal to 1. Okay, and then y equal to x squared. Okay, xy plane. Xy plane, which is z equal to 0. Okay, and then y z plane. Okay, sometimes I can also cannot sketch it correctly, that 3D graph. Okay, because it got combination. Okay, this is x, this is y, this is z. Y plus z equal to 1, so mean here z-intercept is 1, y-intercept is 1, z-intercept is 1. Okay, you have this plane, so should be something like that lah, that plane. Okay, and then y equal to x squared. Y equal to x squared, the parabola. Okay, because z is minimum 0, yz plane is here, mean x yz plane, the wall front, so it's here. So the combination y equal to x squared, you should have some sort parabola, but because okay, bounded by z0 x0, cause here hold on, you got y equal to x squared, this is y, this is x. Okay, y equal to x squared, suppose parabola, you got x positive, x negative, y is positive, so yz plane front, so x is positive only, correct. Some sort like here. So the combination also difficult to view. Okay, but here xy plane z0, yz plane x equal to 0. Okay, xy missing z, so z is 0, yz missing x, so x is 0. Okay, so mean is only and then y, okay, from y plus z equal to 1. Okay, y intercept is 1. So y intercept is 1 here. Okay, because bounded by yz plane x equal to 0, so is okay, only positive part of the parabola, positive part only, x positive. Okay, so now using triple integral volume, okay, let's say okay, we got y plus z equal to 1, we can make z as a title, so I will use dz, and then let's say okay, and I see this curve, I can sum it using vertical bar. This region R, I can sum it using vertical bar, then I will use dy dx. So dy dx. Okay, z. So xy plane, z minimum is 0. So z equal to 0. Upper limit from here. From here, you can get the upper limit, which is z equal to 1 minus y. So 1 minus y. Okay, dy. So from the region R, okay, y from the parabola, which is y equal to x squared. The lower curve, which is y equal to x squared until y equal to 1. Okay, how I get y equal to 1? From y plus z equal to 1. So when z 0, y is 1. So I get y from the x squared until 1. Okay, and then z is x is 0, because y equal to x squared, when y is 1, x also 1. So 0 to 1. So this is a limit for this plane. The plane y plus z equal to 1 bounded with y equal to x squared, xy plane, which is z0, yz plane, which is x equal to 0. I use dz because from here I can express out, I integrate respect to z first, okay, because I can express out, okay, z as a title. From here I know z 0, so this is upper limit z equal to 1 minus y. Okay, so dz, and then the outer, you got dy dx, or you want dx dy. So you have to sketch the region R bounded by y equal x squared, but it's only the right parabola because yz plane x is 0. X is 0 is actually bounded by y-axis. So it's only the right hand side of the parabola, and y up to 1, because from here y plus z equal to 1. Okay, this one tell you, okay, y is actually the y-intercept is 1. Y-intercept is 1. X-intercept also 1. So y is 1. So the parabola, okay, y equal to x squared bounded by y, okay, equal to 1. So lower limit is the lower curve, which is y equal x squared. Upper limit is y equal to 1. Okay. Lastly, x, okay, 0 until here. When y is 1, 1 equal to x squared. So x, you have positive negative 1, but we know x is positive. That's why x, you will take x equal to 1. So each limit that you set up correctly, you have 1, 1, 1. So 3 marks there. Okay, so now integrate respect to z first. So 0 to 1. So you have z from 0 to 1 minus y. So you have dy dx. So 1 minus y. Because you plug in 0, you got 0. Okay. So integrate respect to y. Integrate 1, you have y. Integrate y is y squared over 2. Limit from x squared until 1 dx. Okay. So, and then plug in the limit, the upper limit. So 1 minus, okay, half. Okay, plug in lower limit. So you have x squared. So x squared power 2 again. So x power 4 divide by 2. Okay, simplify, and lastly just integrate using the calculator. So you got half minus x squared plus x power 4 divide by 2 dx. So you integrate here 0.5 minus alpha x squared plus alpha x power 4. How to put hold on. Put up this form. Alpha x power 4 divide by 2. Okay, limit from 0 to 1. So answer 4 over 15. Four over 15 unit cube. There's a question 2b. So question 2c, okay, repeat one more time. Question 2c, same with question 2b, but x is not, but x is unbounded. X is unbounded. So you got y plus z equal to 1. So from here, you know z-intercept is 1, y-intercept is 1. And then y equal to x squared, you draw the region R. In this question, okay, question 2c compared to question 2b, okay, x is not bounded, x equal to 0. So x unbounded from, okay, but we know y is bounded because here y cut by this plane, z equal, y plus z equal to 1, y is 1. Okay, when you put in 1 into x squared, okay, you have x positive -1. So x is from -1 to +1, which is a limit for your x here. And then limit for z, here they already give x bound z 0, which is lower limit. From this plane you get the top surface, which is z equal to 1 minus y. Y bounded lower curve is y equal x squared. Upper curve, which is y equal 1, x -1 to 1. Because the integral up to dz dy, you see the difference is only the limit, lower limit for x change from -1 to 1. So that's why you can get this result up to here. The change, lower limit of x from initially is 0 to 1, you change it to -1 to 1. So the answer is 2 times of the answer in 2b. Find the volume of the solid G bounded by the surface y equal to x squared and plane z equal to 0, z equal to 4, y equal to 9. So you see z, limit of z 0 to 4. We already got limit of z at 0 to 4, so you use a dz, and then y equal to x squared. So limit of the y is from x squared until y equal to 9. So x from -1, from -3 to +3. Not mistaken. Let me see. Find the volume. Find the volume bounded by the surface, y equal x squared. And then planes z equals 0, z equal 4, then y equal 9. And then you do the 2D, yeah? This is x, this is y. Y equal x squared, parabola. And then they say bounded by y equal to 9. This is 9. So when y is 9, x is -3 to +3. So your region R is here. The region R. I can sum it using vertical bar. Then the lower curve is y equal x squared until y equal 9. So x from -3 to +3. Z is 0, until z equal 4. Means actually if you want to view x, y, z, so you got so this one y equal x squared without z. So this solid is actually parallel with the y axis, some sort like here. Then you make it so bounded z 0 until z equal 4. If not, the parabola y equal x squared is actually open up from -infinity until +infinity. So now it's bounded from z 0 until z equal to 4. So it's parallel to z axis. So you use your volume using integrate respect to z first. So the volume because the parabola is actually open parallel respect to z axis. So you integrate respect to z. Z bounded from 0 to 4. I see. Here I got limit of z, so I will integrate respect to z first. Later on, the dA here, you sketch your region R on 2D plane, 2D plane, xy plane. So this will look like your double integral bounded by y equal x squared, y equal to 9. So mean your x, when y is, so y is 9 into x squared, so x you have positive, negative 3. So x is bounded from negative 3 to positive 3. So that's why dx is outside. Because the constant is normally the outermost integral. The y, okay, or we can view this region R, you can sum it using vertical bar, then you use dy dx. So the lower limit of y is a lower curve, which is y equal x squared until y equal 9. Okay, then once you set up the correct limit, then you just integrate it as usual. This is x squared, this is 9. Integrate 1 dz, you have z. So z from 0 to 4, then dy dx. So x squared to 9. So you have 4 dy dx. So integrate 4 respect to, okay, respect to y, you have 4y. Okay, 4, I can factor out the 4. I factor out 4 outside. So I just put out the limit for y. 4, okay, factor out. So integrate 1 respect to y is y. So it's really 4 is factored outside. So that your number, okay, won't be so small, big lah. So you have 9 minus x squared dx. So lastly, put up to your calculator. Okay, 4 outside. So 9 minus, so alpha x squared. Okay, from negative 3 to positive 3. So answer is 144 unit. 144 unit cube. This is question 2D. 2D. So any questions? Okay, for question 2D. Okay, here. So okay, I repeat. Okay, question 2F. 2x plus y plus z equal to 6. So this is a tetrahedron. Okay, z-intercept 6, y-intercept 6, and then x-intercept let y z 0, 2x is 6, x is 3. So this is a tetrahedron, but it's bounded by z equal 1 and the coordinate plane, so x 0, y 0. That's why lower limit for x and y are 0. Lower limit of z is 1 to 6 minus 2x minus y. Okay, to get limit for y, okay, this is a region R bound, okay, region R when z 0. 2x plus y equal to 6, so make y as a title. So y is 6 minus 2x. So y is bounded from 0 until 6 minus 2x. So x, because bounded by coordinate plane, x is 0 until x is 3. Okay, integrate 1 respect to z, you got z. Put up the limit. Then you integrate as usual. Okay, now integrate 1, you got z. So put up the limit, you got 6 minus 2x minus y. Okay, minus, okay, lower limit, which is 1. Then dy dx. Okay, simplify it. So 6 minus 1, you got 5 minus 2x minus y. Then dy dx. Okay, you integrate dy dx. Limit for y 0 to 6 minus 2x. So you integrate respect to y, x is constant. So group this thing together. Otherwise, it's very tedious. Okay. So you got, sorry, 5 minus 2x. You group together. This one. But integrate respect to y, 5 minus 2x is constant. So group it together. So integrate constant respect to y. You have the constant, which is 5 minus 2x multiply y. integrate y, you have y squared over 2. Okay, put up the limit, which is 0 to 6 minus 2x. Okay, those who have class, okay, you want to leave, yeah, you may leave, okay. Okay. So now plug in the upper limit, okay, deduct with lower limit. So you integrate respect to y, so please plug in into y. Okay, you plug in lower limit, everything is 0. So you can skip the lower limit substitution. So 5 minus 2x, y is 6 minus 2x. So minus 6 minus 2x power 2 divide by 2. So you can plug in. It will take longer time to plug in and process. So because, okay, this is 5 minus 2x, this is 6 minus 2x. So we cannot group it together like question 1a. Like question 2a just now. So 5 minus 2x multiply 6 minus 2x. So minus, I got 6 minus 2 alpha x. Then it will square to limit from 0 to 3. The answer is, why I get answer is 9? Okay, I know, okay, where's the mistake here? Okay, the projection scale must be, because z is equal to 1. Okay, so the projection, you have the smaller, okay, triangle. Okay, the mistake is, okay, lower limit of z is 1, so you have to substitute z is 1. So the projection is actually the red, okay, circle. Red circle, okay, mean the red triangle, a smaller triangle where z equal to 1, you got the smaller triangle. So when you plug in z equal to 1, okay, which I should have, okay, 2x plus y, this is 1, so 6 minus 1 is 5. Okay, so y is actually y intercept by 5, x is 5 over 2, 2.5. You have actually smaller triangle. So okay, the correct limit is actually y equal to 5 minus 2x. So x, okay, when y 0, x is 5 over 2. So x is actually 5 over 2. Okay, so the mistake is the projection, you should substitute z equal to 1 because it's bounded by z equal to 1. You got smaller, okay, triangle. So x is actually from 0 to 2.5. Okay, and then y is 0 to 5 minus 2x. Okay, so this is a mistake here. So this is 5 minus 2x. This is 5 minus 2x. So, okay, here, the limit for y is wrong. Limit for x is 0 to 2.5. Okay. So limit for y, okay, is actually 5 minus 2x. Okay, limit for x 0 to 2.5. This is 2.5. Okay. So now, so this is only 5 minus 2x. Then here is 2.5. This one, okay, 2.5. Okay, so again, you can simplify. Where is it already gone? Missing everything. Okay, this one is phi. Okay, a bit lagging. Okay, you can simplify. Okay, here like question 1, 2a just now. So 0 to 2.5. So you have integrate 0 to 2.5. So 5 minus 2x, this is squared. So minus 5 minus 2x squared divided by 2 dx. Okay, like question 2a also. So 1 time of 5 minus 2x squared minus half time of 5 minus 2x squared. So you have half time of 5 minus 2x squared dx. Okay. So you got half of 5 minus 2x squared. Okay, limit for x 0 to 2.5, which is 10.4167. 125 over 12. So you get the answer is 125 over 12. Okay, or 10.4167. Okay. So you can see the correct limit is very important. This question 2f, because z is bounded by z equal 1. So the projection is actually you project the red color triangle onto your xy plane. So you got the smaller triangle. Okay, how to get this smaller triangle? Substitute z equal to 1. So you got 2x plus y equal to 5. Then upper limit of y will be y equal to 5 minus 2x. Okay, and upper limit of x. Okay, when let y 0, 2x equal to 5, so x is 5 over 2. Okay, so limit for x 0 to 2.5, limit for y 0 to 5 minus 2x, limit for z is actually 1 to 6 minus 2x minus y. Okay, and then you evaluate it like your question 2a. Okay, last integral, you can use your scientific calculator. So you obtain the answer 10.4167.